common functions. The two functions we're going to hit specifically in this chapter, and we're going to hit the first case here the most. The two functions we're going to deal with in chapter 1 are going to be linear functions and quadratics. All right, and so first, a review of linear functions. So this should be a review of lines, right? A linear function is always in the form y equals mx plus b. That's the function form of a line. It's also the slope-intercept form of the line because those are the parts that are given to us. The m part in that equation is the slope. The b part is the y-intercept, and so that's also known as the slope-intercept form, if you read that, of a line. Slope is very important. We'll be finding slopes. All right, slope is important for linear functions. It's also important to understand what it is. For lines, it's constant, meaning it's the same. No matter where I'm at on the line, the slope is the same. All right, it gives you the rate of change of the function over any interval. All right, and so the slope is, and I'm going to talk about a little more what it means because it's important to understand what it means. All right, but in words, the slope is the change in the function, change in the y values, over the change in x. Alright, so usually you find change by taking the difference, so it's y2 minus y1 over x2 minus x1, where the y values are the function values, right? My function values are my y values. Another way, again, they typically talk about it is rise over run, right? It's the vertical change and the horizontal change. And so what the slope finds in a line, it's constant, it's speed and direction. That's what slope is. Alright, so slope is the speed and direction the line is moving. The function is moving. So speed would be how big. Direction means positive or negative. And so it's the how fast the function is increasing if it's a positive per change in x. Per change, you're going to read that, per change in x. Or how fast the function is decreasing. It's negative per change in x. Alright, so that's what and it's constant. No matter where I'm at on my line, if I can find slope, and slope gives me how fast the line is moving up if it's a positive slope, or moving down if it's a negative slope. So it's the speed part is the size. Direction would be moving up or moving down. So positive means it's moving up, negative means it's moving down. And so how fast, the bigger the number, the faster it is. It's the steeper the line, right? How faster it is. And then again, the positive and the negative are what direction it's moving in. Right, so a review of finding slopes. So again, slope and linear equations. So this should be something you've done before. So I can find slope as long as I have 2 points on my line. Okay, so we're going to look at a couple of examples, and so we're going to find slopes. So remember, slope is the change in y, which is the difference in y over the difference in x. And the biggest thing is just make sure you're consistent. If you pick one point to start with, that's the one you should always start with. I have to do the change in y over the change in x. Alright, so difference of. And so it's up to you, whatever you want to, you could do your subtraction slightly differently than what I do, as long as you're, and what I mean by consistent is, oops. Let's pick a highlighter. Alright, y2 minus y1 over x2 minus x1. Those numbers should come from the same pair. Right? And y1 should come from the same pair. So y1 and x1 should come from the same pair. So if I let this be my second point, my 5, negative 1, 2, 8 is my first point. So again, my y value is negative 1 and 8. So I take negative 1 minus 8. And then my negative 5 and my negative 2 are my x. So negative 5 minus a negative 2. And again, what I mean by consistency is the negative 5 and the negative 1 came from a point, and the 8 and the negative 2 came from the other point. And so that's what I mean. You always have to be consistent. So I could have flipped this around and done the subtraction in the opposite order. As long as I'm consistent, the x value and the y value paired together should be above and below each other. Up top, -1 minus 8 gives me a -9, and the bottom 5 minus a -2 is really 5 plus 2, and that's -3, and that simplifies to 3. And so my slope is 3, and so that tells me the line would be increases by 3 units per change in x. By 3 units per change in x. So it should be moving up, right, by 3 units per change in x. The next ones actually are special cases, and you should always be aware of special cases when they exist. Alright, so again, slope is the same thing. I'm going to use the same equation I've written in part A, so it's the change in y over the change in x. And so my y values are -2 and 5, so -2 minus 5. My x values, though, if you'll notice, are both 3. So when I take 3 and subtract away 3, in the bottom I'm going to get 0. Up top I'm going to get a -7. Not that it matters. What matters is that 0. And so this means, right, we can't divide by 0. Undefined slope. Well, undefined slope just means it's still a line. It's just a very special line. It's a vertical line, a line moving straight up and straight down. Right? So there's technically no increase because I'm doing both at the same time. That's why it's undefined. I'm moving up into infinite, positive infinity, and negative infinity perfectly straight. And so there is no speed or direction because it's moving both directions. It's going positive and it's going negative. All right, and so that's why it's undefined. Well, sort of why we can't define it, but it's undefined because I get division by 0. All right, so that's a special type of line called a vertical line. C is also our special type of line, so it's the other case. It's going to be our horizontal line. All right, up top is my change in y. Well, my y values are both -3, right? And then my x values. So up top I get 0, and the bottom I get 1. I can't divide by 0, but I can divide into 0. You could take 0 divided by 1 on your calculator, and you'll get 0 out. And so this means my slope is 0. Well, a slope of 0 is the other kind of special line. When I get a slope of 0, this is a horizontal line. It's a perfectly flat line. And it should make sense. Slope is speed and direction. If it's perfectly flat, all of my y values are the same, and it is neither moving up nor moving down. There's no increase, no decrease. It's staying exactly the same. It's a constant line, constantly the same value, and so it should make sense. There's 0 increase, 0 decrease, therefore my rate of change is 0. All right, horizontal line, a flat line is 0. All right, more fun with lines. So basically we're kind of hitting all the big ideas about lines. Again, lines are something you should have talked about in an algebra class. So the next thing about a line is I want to be able to find x and y intercepts. These are going to be important. When we get to chapter 5, this is going to be very important when we get to chapter 5. We're going to be using x and y intercepts to graph stuff in order to solve systems of inequalities in chapter 5. So you should be able to find x-intercepts and y-intercepts. So we'll start with the x-intercept. The x-intercept's where it crosses the x-axis, right? This is when it crosses the x-axis, which means the y value is 0 and I have to find the x value. All right, so that's what we do. We take this equation, plug 0 in for y, and solve for the x. And so we're just left with 2x equals 10, divide out my 2, and so my x-intercept is 5. The point where it crosses the x-axis is 5, 0. I do something similar for the y-intercept. The y-intercept where it crosses the y-axis. So the x is 0 and I solve for y. So that's what we do. We take 0 for x, plug it into our equation. 2 times 0 is just 0. So actually this one's a little easier. It just leaves me with y equals 10. And so y equals 10 is my y-intercept. And so the point where it crosses the y-axis is 0, 10. And those points help us graph. We like to find the intercepts to help us graph. Sometimes it's where our applications start, or at the intercepts, and so they're important. So remember, x-intercept crosses the x-axis. The y is 0. I've got to find the x value where it crosses the x-axis. The y-intercept is the opposite of that. It crosses the y-axis. When it crosses the y-axis, x is 0, and I've got to find the y value on my y-axis. And so I plug in the 0 for x and solve for y. Alright, now solving equations, finding linear equations. So the first one is find the linear function whose graph passes through the point 5, negative 2, and is parallel to the equation 3x minus 5y equals 8. Write your answer in the form of a function, linear function, which is the y equals mx plus b. Alright, so first of all, what's important here is they give me a parallel line. So you've got to remember parallel lines, the slopes are the same. So parallel lines have the same slope. So that means I get my slope by using this equation. So I'm going to use that equation to find slope. So my 3x minus 5y equals 8. I want to find my slope. But we do that by solving for y. Solve for y, because that's going to put it in the form mx plus b. Okay, so solve for y. The first thing I got to do is move my x term to the other side. So I'm left with negative 5y equals negative 3x plus 8. Divide by my negative 5. Remember, I divide everything when I divide. And so y equals 3/5, because the negatives reduce, cancel out. X minus 8/5. Now the negative 8/5 isn't important, but that is what the y-intercept would be. What I want is the m part. And so that tells me that line has a slope of 3/5. That line is parallel to the line I'm looking for, and so the line I'm looking for has a slope of 3/5, and then they gave me a point and passes through the point 5, negative 2. Alright, so now there's different ways you could do this. You could use the point slope equation and solve. I'm just going to use the y equals mx plus b. I think when I post my notes later on, I use the other form, so if you want to remember what the point slope form is, when I post my completed notes, that's how I solved it there. But this one I'm going to use the y equals mx plus b. I'm going to plug in my m, my x value, my y value, and I'm going to solve for b. Alright, so y is negative 2, slope was 3/5, x was 5, b is the only part I don't know. It's kind of nice, the 5's reduce. And so negative 5 is my b. And so my final answer then, that's my work. My f of x is equal to my slope, right? I want to put it in the form f of x equals mx plus b. My slope was 3/5, and my b was negative 5. Alright, there's my answer. Next example. Right, find the linear function whose graph passes through the points 3, 10 and 5, 5. So 3, 10 and 5, 5. So this case, I'm given 2 points, which means I'm going to use my slope equation to find it. So first thing is we find slope. So slope, remember, is my change in y over my change in x. And so in this case, 5 minus 10, and then 5 minus 3, so I get negative 5 over 2. And so my slope is negative 5 halves. Alright, then I want to find my line, y equals mx plus b. I need to find the b part. I know the m part. I don't know the b part. And so, again, you can use the point slope equation, which again, if you go look at my notes that I filled out, I did do the point slope equation there. I'm going to, however, use my y equals mx plus b. I'm going to use one of my points. I can use either one, but I'm going to use the 5, 5 because it's the easier case. That way I can't mess up plugging in y and x. Because they're the same. Y is 5, x is 5. So I'm going to plug in my 5 for y, 5 for x, my slope for m, and then solve for my missing piece, which is my y-intercept, my b. So 5 equals negative 5 halves times 5. So this one's not going to come out as nice. So 5 equals negative 25 over 2 plus b. Add 25 over 2 to my 5. So just going to add my 5 plus 25 over 2, which comes out 17 and a half. Or if I use my fraction key on my calculator, 35 over 2. Now I've got all the parts that I need. Now my final thing is to write the answer in the form f of x equals mx plus b. And so the answer is f of x equals m, which is negative 5 halves, x plus b, which came out 35 over 2. You could do the decimal version of that. So 35 over 2 is 17 and a half. Negative 5 halves would be negative 2 and a half. So if you prefer the decimal version, this one you could, because they're nice decimals. Negative 2.5x plus 17.5 would also be a fine solution. Alright, where we don't want to use decimals is whenever we get something like a third and it doesn't come out really nice. We don't want to round those. Alright, the last one. Sketch by hand. You can always check using your graphing calculator, and it's fine if you use it. It's one of the nice things about having a graphing calculator is you can always use it. Alright, but I'm going to graph this one by hand. So I'm going to graph y equals negative 1 half x plus 3. And so I just need 2 points. Well, I've got one already for me to go, right? Whenever you graph a line, you need at least 2 points. Sometimes we get a third point just to make sure my line came out right. But 2 is the minimum. I need at least 2. And 1 point's always easy to get. I know my y-intercept, right? Because I know b is 3. Well, that's the y-intercept, which is the point 0, 3. And so I always do that one first. And then I just need any other point, which usually just means pick an x value and find the y value that goes with it. Now, looking at my equation, I know I've got to multiply by a half. And so it's just a good rule of thumb to pick an x value that's even, so it divides out the half, so I don't have a fraction in there. So 2, 4, negative 2, any of those would be fine. I'm going to pick 2. Alright, plug it in my equation. Negative 1 and a half times 2 plus 3. Oh, actually, that comes out really nice. That comes out to 0. And so I actually found both my intercepts. 2, 0, 3, 0, and those are the two I'm going to use to graph it. You can always check your answer on the calculator. So there's my y-axis, there's my x-axis, so 0, 3 puts me there, 2, 0 puts me there, and then you just draw as straight a line as you possibly can, and there's my line. Alright, and so again, this is a quick review. It's just a very quick review of lines. Lines should be something you've seen before. We'll be doing lots of things with lines. We're going to get to applications of linear equations. Actually, that's the next 2 sections in Chapter 1. Chapter 1, 1.3 are finance applications. And then Section 1.4 is linear regression. So we're going to do lots and lots and lots with lines. So it's just a review of finding the slope of a line, finding the y-intercept of a line, finding the equation of a line, and graphing a line. So hopefully you're familiar with lines. Alright, we'll stop there. With these specific